we are discussing Born-Oppenheimer transformation. Since rotational energy levels are separated by 1 to 10 centimeters, where vibrational energy levels are separated by 100 to 1000 centimeters, so a molecule can execute rotational and vibrational independently. Now delta E mu j equal to delta E j plus delta E mu centimeter inverse, and total, what have you done? Shit. Okay, now it is good. Okay, so delta E mu j, remember this, mu and then j, what will delta E j plus delta E mu, which will be in centimeter inverse, j and mu. So total energy will be rotational plus vibration in joule, and this is rotational plus vibration in centimeter inverse. Now for diatomic vibrating and rotation, so what Born-Oppenheimer suggesting us, that rotational energy levels are, this is separation, and for vibrational separation is this, so gap is very high between these two, so a molecule can execute rotation and vibration independently, है ना. वो एक ही मोलिक्यूल रोटेशन भी दिखा सकता है और वाइब्रेशन भी दिखा सकता है, उसका पता करना है आपको. नाउ डायटोमिक वाइब्रेटिंग रोटेशन, ई जे म्यू इक्वल टू ई जे प्लस ई म्यू, so ई जे म्यू इक्वल टू दिस फॉर नॉन रिजिड एंड फॉर हार्मोनिक बी जे प्लस माइनस डी जे स्क्वायर जे प्लस दिस फॉर नॉन रिजिड म्यू प्लस 1/2 का ई ओमेगा ई माइनस का ई म्यू प्लस 1/2 स्क्वायर ओमेगा ई विच इन सेंटीमीटर इनवर्स. Selection rule for this Born-Oppenheimer transformation means rotation and vibration simultaneously, independently, sorry, plus minus 1, then delta j plus minus 1, delta j equal to 0 is not allowed. So each vibrational change must be accompanied by a simultaneous rotational change. ठीक है, hope you got it. चलो next movement. So E j mu equal to E j bar mu minus mu 1 and E j bar mu equal to 0. Got my point or no? Note, we have divided in two parts. This is j bar ground for mu equal to 0 and for mu equal to 1. So mu equal to 0 we are considering for ground, means for vibrational there are certain rotation, for vibrational inside rotational simultaneously, for each vibration there are certain rotational energy levels also. So for ground state we are representing by bar, and for double bar, and for first excited state we are representing single bar. So just push it here and solve it and put mu equal to 0 for ground, for double bar, and you are having the final answer omega bar b j j bar minus j prime minus j double prime j prime plus j double prime plus 1 centimeters, where omega bar equal to omega e bar minus 2xe. Now let's consider for delta j equal to plus 1, where from here to here 0 to 1. So what will be happen, j prime for final minus initial, j prime minus j double prime equal to plus 1. So just put here, means j minus j prime double prime equal to plus 1, and from here you can calculate j plus prime, what will be happen. So 2b j prime is 1 plus j double prime, 1 plus j double prime, solve it, you are having 2 j double prime plus 1 in centimeter, and it will be plus 1. Now for del j minus 1, j minus j double prime, final minus initial. Okay, for minus 1 what will happen, by final minus initial, j prime minus j double prime equal to minus 1. So just put the value and you will giving this expression, and delta j equal to 0 is not possible. So it is for emission, initial minus final. Initial is j prime 1 minus final 0 equal to final minus initial. Final, what is final? Final is 0 j prime minus j double. What is j prime? Here 1 minus j double prime is 2, so 1 minus 2 equal to minus 1. So simply you have to do initial minus final. Now let's move forward. Delta E j equal to mu spectrums omega naught bar plus 2b m, which is m equal to plus minus 1 plus minus 2 plus minus 3, omega naught bar bend origin, which is bend center, j equal to 0 to 1. It's possible, you know, delta j equal to plus minus 1 is possible. So it is possible. 1 2 is possible. 2 minus 1 equal to 1. 1 minus 2 equal to minus 1. From 1 to 1 it is not possible because delta j is not equal to 0. So just remember 2bm for this. Now what will the lines? Delta is 0, plus 1, plus 2, minus 1, minus 2. So for 0 it is q, which is forbidden for here, and p equal to minus 1, p equal to minus 2, p delta is equal to minus 1 for p, delta is equal to plus 1 for r. Now m equal to 0 and m equal to 1. So how many transitions are possible? Let's suppose delta is equal to minus 1. So how many transitions possible? Delta is equal to minus 1. From 0 to 0 is not allowed. From 1 to 0 allowed. From 1 to 0, but we have to calculate delta is equal to minus 1. Let's suppose delta is equal to minus 1. So what will be happen for minus 1? Final minus initial. For absorption, final minus initial, absorption. So just do it. What is final? This 0 minus 1 equal to minus 1. Here 1 minus 2. Here 2 minus 3. So it will be j equal to j minus 1. Now for here part, what will happen? We final minus initial. So final is 1 minus 0, 1 minus 0 plus 1. Here 2 minus 1, and here 3 minus 1. So this will be called P line, this will be called R line, and central is Q line. And so this is called R0, R1, R2. The gap between R0, R1, R2 is 2b remains same, and for P1, P2, P3 is 2b, 2b, and for R0 and P1 is 4b. From where you calculate? From here. Delta Ej mu omega naught plus 2bm. So just put it here, plus 1, plus 2 and plus 3, 2b, 4b and 6b. Here minus 1, minus 2 and minus 3, 2b minus 4b and 6b. So this is P1, P2 and P3. This is R0, R1 and R3. So just omega naught minus 2b, omega minus omega naught cancel, minus 2b, minus 2, which is appearance of 4b. So what is the maximum quantum number? Kt upon 2bsc minus 1 by 2. Where m equal to j plus 1. For maximum intensity we will having R line, and for maximum intensity of P line, this is R and this is P. So for R line what we are having? Omega naught plus 2b in this part, and for P line here is minus. Now separation between two maxima in low resolution case, delta mu bar equal to 4b under root kt upon 2bsc plus 1 by 2, 4b under root kt upon 2bsc, where b is small, and delta mu bar equal to 8 by kt upon sc, where b is delta mu bar square sc by 8 kt. Now this is Vp maximum, this is R maximum, difference is delta mu bar. Now what will the breakdown of Oppenheimer approximation? Let's see it. In practical situation, rotational and vibrational are not truly independent, and actually they affect each other. It means B values of potential levels now not same for all vibrational levels. In other words, means what we are having, practically rotational vibrations are not truly independent, they affect each other. Means the B of rotational levels is not same for all vibrational levels. So there will be correction in B for vibrational level, which is B minus alpha mu plus 1 by 2. So which is B mu is rotational constant for mth vibrational level, and B is equilibrium value of P, alpha is a small constant. According to Born-Oppenheimer approximation, this all is equal to, but reality is different from this. So Born breakdown, B naught is highest, then B1 and then B2. Now we have question, diatomic molecule is there, vibrational states with energy mu, and rotational state with energy this. Very good, it is given to us for vibrational and for rotational. And for rotational. Now mu and j are negative integers. Consider a transition in which both initial and final state are restricted to. Now we have given to us quantum number for vibrational and for rotational. Selection rule also given to us. Then the largest allowed transition laser. So first we have to find out what are the transistor levels, and both are combined, so bone Oppenheimer. So to calculate lattice energy level, so mu equal to 0 and mu equal to 1 given to us, mu equal to 0, 0 and 1, and mu equal to less than equal to means 0, 1 or 2. So j equal to 0, 1, 2, j equal to 0, 1, 2, for mu equal to 0, for mu equal to 1. This is ground, this is first one. So first energy is 0, 0 to 1, 1. We write j into mu, j and mu. So j mu is, pay attention, from 0, 0, both 0, both 0 to both 1, both 0 to this is both 1, means 1 minus 0 equal to plus 1, possible allowed energy level, and the line will be this, separation will be this far, image will be this, and separation increases in j. We know this separation is increasing with increase in j number, so highest will be for two part. But let's see another example. E j mu 1, 0 equal to j equal to 1 and mu equal to 0, j equal to 1 and mu equal to 0, this one 9, from 0 to 1, j equal to 0, 1 to 0, 1 to 0. You can clearly see this energy level higher than this energy level, so this is out. Now equal to 2, 0 to 1, 1, this is 2, 0 to 1, 1, this part, this also less energy level than as compared to this, but so this is not required to calculate for us. Now E10, E10, this is 10, this, sorry, 10 to 1, 10 to 1, to this is 1, this is the highest energy level, and you can calculate delta E j equal to 2 to mu equal to 1, so j equal to mu equal to 0. So just put in the bjj plus 1 plus h cos omega mu plus 1 by 2, bjj plus 1 h cos omega mu plus 1 by 2, bjj plus 1, and you are having the answer. Now the expression for second overtone frequency and vibrational absorption spectra of a diatomic molecule of in terms of harmonic frequency omega e and constant chi e. So just we know this second overtone, this is for first, this is for second, sorry, this is for fundamental, first overtone, second overtone, and for second overtone we know 3 omega e, so this will be out, and this here, this will be 4. The spacing between vibration energy level in carbon monoxide molecule is found to be this force constant we have to calculate. Every exam question asked. So we know that delta equal to h cross omega equal to h cross under k upon mu, omega equal to k upon mu, which is in joule. Just put the value, and you are having k equal to delta E mu square, delta E square mu by h square. Just solve it. 187 Newton per meter. The equivibrational frequency for an oscillator is observed at this, given to this. The ratio of frequencies corresponding to the first and fundamental spectral line is 1.96, considering the oscillator to be enharmonic. The enharmosity constant is chi is. So we know that this is for fundamental first. So for first is 2 and fundamental is omega. 2 is here, so this is 3, 1 is to 2. Just solve it, and you are having the answer. Now we'll discuss about the vibration of polyatomic molecule. Thank you very much.